Students, what's up? We're going to do lesson 1.3. Now we're going to do this a little different. Normally I just do photocopies of the book and I just refer to the guided questions, but there's a couple of problems where I'm actually going to go to the 1-3 notes and fill out a couple of things. So there's going to be a little bit of dynamic movement going on here, but I'm pretty sure you'll be just fine. So talking about square roots, it's kind of the big idea. We're simplifying square root expressions. We're comparing the different flavors of numbers in lesson 1.3, and there are lots of flavors of numbers. We'll talk about those in a second. But we're talking about square roots. What is a square root? Basically, I think of it this way. If tree roots build trees, square roots build squares. If you want to make a square that has an area of 25, you need to build that with a 5 by 5 side. The 5s are what build the 25. So how do you find the square roots? Well, that's what the square root button does. If you want to build a square of 81, you need sides of 9. If you want to build a square of 9/16, you're going to need 3/4 on each side. So where is the square root button in my calculator? It is right here, and it goes with the square. There's a reason those go together, because they cancel each other out. Okay? It's kind of like how addition and subtraction and multiplication and division cancel each other out. Squares and square rooting will cancel each other out. Okay, so let's check to see if we can get the same things that they get. Here we go. Square root 81, send it. Yep. Square root of 9/16. Now make sure the radical sign goes over the entire thing. All right, otherwise you might have to use grouping symbols. Now they give you a decimal, 0.75, but again, math fraction would be 3/4. An extension of this is that if you do a radical sign to 9/16, that's actually the same thing as the square root of 9 over the square root of 16. So the square root could actually spread down or split and spread to each individual number. So kind of a neat little idea. Maybe we'll use that in some of these down here. So here's the guided question. Here's what you do in your notes. Okay, for the guided question. So 1a, square root 64, square root 25, square root 1 over 36, or 1/36, and then square root 81 over 121. So here we go. Get a head start, but here's the answers. Here we go. Square root 64. If you know your squares, your perfect squares, there is room on your notes to make a list of the perfect squares. Well, it's basically just an extension of this list. Okay? 1 is going to make 1. There's 4. There's 9. There's 16. And then you kind of continue the list right there. 64, by the way, is on that list. So the square root of 64 is 8. If you have an 8 by 8 square, you're going to make a square that is 64 for its area. Square root of 25, already did that one. You're 5. Now, you can use this idea and do the square root of 1 over the square root of 36. Okay, again, this is, photocopy of the book. Don't write in the book. You should be writing this on your notes. So the square root of 1 is 1. Square root of 36 is 6. 1/6. Let's try to put them in a calculator just to double check and just to be safe. Square root 1/36. Ew, gross. A decimal. Math fraction. Boom. 1/6. Got them. Okay. Again, this would be the square root of 81 over the square root of 121. So I'm kind of distributing the giant radical and making two smaller radicals. By the way, the square root sign is called the radical sign. Hopefully you wrote that down somewhere in your notes. I think these are vocabulary things, so write those down somewhere. You get the idea. All right, square root of 81, I believe, is 9. Already found it. Hey, look at that. And then 121 is 11. Again, 9 and 11, 81 and 121 would be on that perfect squares list. Okay, so the reason, really quick, the reason that square and square root are the same button is because they kind of undo one another, okay? So watch this really quick. If I take 13 and I square it, I'm going to get that number. If I take the square root of 169, guess what? It turns it right back into 13, okay? It's like 13 times 2, and then divide by 2. I'm back to 13. Or 13 plus 5, and then minus 5. I'm right back to 13, okay? So squaring and square rooting cancel each other out. That will be a skill you will need in the future. Okay, how do you make perfect squares? You just square the numbers, all right? So again, make that list somewhere, somehow, some way. We're going to jump right into I didn't really do problem number 2. I just jumped right into the question. So we're going to use those perfect squares, to estimate square root. So we're going to estimate the square root. The square root of 45 would be in between which numbers? Well, if you think about the perfect square list, the next perfect square after 45 would be 49. The first perfect square before that would be 36. So the square root of 45 has got to be between 6 and 7. You kind of see how that works? Okay. The square root of 67, well, that's got to be between the perfect squares. The next perfect square, I believe, is 81. Okay. The previous one would be 64. Okay, so I should probably put these symbols like that. There you go. Probably should do that. Okay, that's 9, and that's 8. There you go. Let's double check really quick. Square root 6, 7. Hey, look, 8 point something. It's between 8 and 9. So in between the nearest whole numbers. 155. Ooh, I don't know. I don't have a perfect square list in front of me. I think 12 squared is pretty close. 13 squared. Wow, good job. I am a math teacher. I guess I got pretty lucky there. 169, 144. So that would be between 12 and 13. Okay. So that's kind of getting out of our range of memorizing things. We're not going to do too many of those, but still, it's a skill you can figure out. If I do the square root of 155, hey, look, it's between 12 and 13. Okay. Pretty simple stuff. So that's problems 1 and 2. Okay. From page 17, and then I didn't really do problem number 2. I just went right into, look at it. It says no calculators. Whoops. I guess to check, okay. Estimate without calculators, but you can use calculators to check. Okay, to check. Okay, maybe we should follow my own rules. All right, problem number 2, we just did. We'll move on to some number flavors here in a second. All right.